Welcome to the Pact Smart Contract Programming Language. In this tutorial, you'll learn all about Pact, get introduced to its core features, and take your first steps towards becoming a Pact Smart Contract developer. The goal of this tutorial is to familiarize you with what Pact is, how it's used, and some critical decisions that influence the design of this new language. Pact is the safest, most user-friendly language for smart contracts. It's designed for security and performance. Pact is an open-source programming language for writing smart contracts. It's designed from the ground up to support the unique challenges of developing solutions to run on a blockchain. Pact empowers developers to create robust and high-performance logic for transactions. It facilitates execution of mission-critical business operations quickly and effectively. Pact is designed with safety in mind. Its design is informed by existing approaches to smart contracts as well as stored procedure languages like SQL and Lisp. Pact resembles a general-purpose, Turing-complete language. It includes Lisp-like syntax, user functions, modules, and imperative style. Pact takes a unique approach to smart contract development. Pact smart contracts contain three core elements: the module, key sets, and tables. First, a module defines the logic of a smart contract. It contains functions, Pact definitions, tables, and schemas. Next, Pact key sets specify authorization to different parts of the smart contract. They determine which accounts have access to which parts of the program. Finally, tables store data generated by Pact modules. These tables have a key row structure and support schemas as well as a versioned columnar history. Each of these elements support a wide range of functionality. This ensures that you have the tools you need to create robust solutions for real-world problems. There are many valuable features that make Pact such a safe and high-performance language. These features include Turing incompleteness, human readability, upgradable contracts, formal verification, and many other features. These come along with Pact's unique tooling ecosystem and developer community. All this makes writing smart contracts with Pact both fun and productive. Let's take a look at each of these features in more detail. First, Pact is a Turing incomplete language with deliberate constraints. This is done to help keep your code safe. Here's why. For some applications, Turing completeness is an extremely important feature. For smart contracts, it's an incredibly dangerous feature that exposes developers to dangerous and costly attacks. For that reason, Pact is designed to be Turing incomplete, which places deliberate constraints on its computational ability. This supports its design goal of just enough power for transactional blockchain solutions and helps ensure the security of its smart contracts. To maintain Turing incompleteness, Pact does not allow unbounded looping or recursion. Pact detects recursion and fails immediately. Looping is also only supported in special circumstances. The key benefits of this are to reduce cost and improve performance. Turing incompleteness makes some of the most infamous and costly bugs discovered in other platforms not even possible with Pact. Next, Pact is human readable. All Pact code gets stored and written in human readable form on the ledger. Pact smart contracts install directly onto the blockchain. This allows you to review the running code as it was written and be sure of exactly what it's doing. So why is this important? Well, smart contracts solve business problems that require both technical and non-technical expertise. Building the best smart contract solution requires everyone to understand and contribute to the development of the smart contract. For that reason, Pact was built to be simple to read and write. This simplicity helps provide complete transparency for the logic within its smart contracts. This approach also encourages shorter programs. The code executes directly on the ledger where it can be read easily by anyone. As a result, Pact is easy to understand. For example, here's a Hello World smart contract using Pact. Without having learned anything about the Pact language, you can already start to see how it works. With these few simple lines of code, you see a fully functioning Pact Hello World smart contract. Pact also supports upgradable contracts. Upgradable contracts allow you to offer new features, adapt to new workflow requirements, and fix bugs as they're discovered. None of this is possible with other smart contract languages, and it's a powerful feature when building impactful applications for your business. Pact's tooling ecosystem further amplifies the simplicity of upgrading contracts. Compiler and runtime errors offer detailed information, with stack traces and function documentation to ensure you're making the best version of your smart contract. Pact's iterative development process is also supported by a feature-rich REPL, helping you to improve and deploy new smart contracts rapidly. It includes features such as incremental transaction execution and environment and database inspection. Finally, Pact comes equipped with a powerful validation tool suite in the form of formal verification. Pact uses Z3, an open-source tool developed by Microsoft to mathematically verify and test for bugs present in the code. This means that Pact allows smart contract authors to express, automatically check, and formally verify that their code does not contain any bugs. Formal verification is the same system used to protect mission-critical environments like nuclear power plants or airspace and autopilot systems. You now have the same high level of security in every smart contract you write with Pact. Along with these core features, there are many other features that Pact supports to help make your developer experience as rewarding as possible. Here's a quick overview of these features. First, Pact includes type inference. This feature makes it possible for code to be strongly typed without declaring type information. It also has the added benefit of limiting runtime type enforcement. Developers can use a type check to add just enough types. Type check eliminates warnings and only enforces types at runtime where needed. Next, similar to relational database management systems, Pact offers the benefit of total governance. This benefit allows changes to commit to the database only if the code runs successfully. Any errors roll back changes, abort execution, and avoid costly mistakes. Pact is also designed to allow direct integration with an industrial relational database management system. This design is helpful in cases that need efficient publication of historical data. The Pact programming language name comes from one of its key features, known as pacts. A pact solves a significant blockchain problem in privacy-preserving blockchains. To maintain privacy on a blockchain, participants can only run a subset of smart contracts. In these cases, the databases of each of the participants become disjointed. Pact solves this problem using coroutines. Coroutines are functions that can start and stop at critical points in a function's execution. These coroutines are called pacts. They define the steps to be executed by different entities as sequential transactions on the blockchain. The features described here are only a few of the crucial features that make Pact such a powerful language for writing smart contracts. There are many resources available to help you learn even more about Pact. Before wrapping up, here's a look at some of the resources you can use to get started. You can join the Discord channel for community discussion. Read the Pact Smart Contract whitepaper to learn more about the creation of Pact. Go through the Pact documentation for a detailed look at everything the language offers. Follow the GitHub page for the latest updates on Pact development. You can also ask any questions that come up while you're learning Pact on Stack Overflow using hashtag pact-lang. And to get coding right away, you can go to pact.cadena.io to use our online code editor that allows you to easily build and deploy smart contracts using Pact. Along with all of these resources, you can also continue this tutorial series. Throughout these tutorials, you'll learn all about Pact by walking through each of its features, building real-world applications, and exploring new ideas for yourself to take the language in directions no one has even thought of yet. That wraps up this tutorial. Throughout this tutorial, you learned about Pact, got introduced to its core features, and took your first steps towards becoming a Pact smart contract developer. You also know where to find us, the community, and many valuable resources to help you get started developing with Pact. Feel free to join the community and reach out if you have any questions. We're incredibly excited to help you start your journey as a Pact smart contract developer. So, welcome again to the Pact programming language. We can't wait to see what you build.